Assalamu alaikum. Welcome back to our channel, Digital Future AI School. Kindly subscribe our channel, like and share with friends. And this is the episode 29 of book AI Agent Makers, written by Mr. Zahir Ahmad Mir. Today, we're undertaking a deep dive into something that honestly feels like the grown-up part of AI. We're talking about structured output, the real production-grade backbone of serious AI agents. Our mission is to dissect the crucial Appendix S from the book AI Agent Makers, the 50 ready-made JSON schemas. This is really the moment AI stops being just a creative writing partner and, starts being a reliable industrial-scale automation engine. Okay, let's unpack this. When people talk about AI's potential, they often show off a beautifully written essay or a clever piece of code. But if you try to integrate that raw text into a serious workflow, say pushing sales data into a CRM or updating a legal database, you just hit a wall.
You absolutely do. Raw text is messy. It's unreliable. So what exactly are these 50 schemas, and why are they described as the production-grade, copy-paste-ready solution?
That distinction you just made, the difference between, let's call it narrative text, and a defined structure, that is the entire point of this appendix. And frankly, it feels like the maturation of the entire AI field into a truly functional technology.
It really is. A large language model's raw output is, fundamentally unreliable for automation. It might miss a date, it could flip the order of arguments, or it might just invent a formatting convention that's unique to that one single session. You can't build a business on that.
It's too unpredictable.
Totally. These schemas are the necessary templates, the contracts, if you will, that we impose on the AI. They convert that raw, verbose, and potentially chaotic output into standardized, validated data, specifically JSON objects, that can be immediately and safely plugged into enterprise systems.
Like data pipelines, web applications, or even those no-code tools a lot of people are using, like Zapier or Make.
Exactly. They are rigid structures that force the AI to not just say something, but to structure it according to predefined machine-readable rules. It's a profound shift.
So instead of just saying, hey, summarize this data for my database, and then, hoping the AI puts the numbers in the right column,
Right.
we're essentially giving the AI a perfectly formatted, fill-in-the-blank digital form. If a field like Case ID is mandatory, the AI knows it must find and extract that data and put it in that specific Case ID field.
And if it can't, the whole thing fails. The entire output gets flagged as invalid. That's the critical insight. It imposes accountability and auditability right from the start.
And the applications listed here, they really underscore just how practical this is. We're talking about automating complex legal reporting, standardizing educational assessments, even generating pitch decks.
It's not theory. This shift from unstructured text to structured data is the real difference between a novelty chatbot and a functional commercial AI agent.
All right, to really appreciate the necessity of this rigidity, I think we have to start where precision matters most, the legal system. This first category has 10 schemas dedicated entirely to legal workflows. So why is structured output so absolutely critical when you're dealing with law, where a misplaced word or a single omission could lead to disaster?
Well, the law operates on precedent, on defined terminology, and on mandatory disclosure. Legal documentation demands not just accuracy, but rigidity in its presentation.
There's a reason legal documents look the way they do.
There is. If an AI agent is summarizing a case for a legal tech platform, its primary goal is extracting the binding elements in a way that allows for machine cross-referencing and database ingestion. These schemas ensure essential information is never missed and is standardized for immediate use.
So let's get into a specific one, the Legal Judgment Summary Schema, S1.1. This seems to go far beyond just a simple narrative summary.
Oh, way beyond. It mandates fields like case title, court, facts, and issues. But the two fields that really elevate this to a true automation tool are ratio decidendi and final order.
Okay, that term, ratio decidendi. I know it's the legal principle, the reason for the decision, the binding precedent itself. But for those of us who aren't lawyers, what is the structural significance of forcing the AI to isolate just that one element?
That's where all the power lies. Think of a human lawyer who has to sift through a 50-page judgment, highlight the core legal reasoning, and then manually summarize it. It's incredibly time-consuming.
And prone to error, I'd imagine.
Very. This ratio decidendi field forces the AI agent to ingest potentially thousands of words of judicial language, which can be complex, verbose, and instantaneously structure the single most important binding legal principle from all that text.
So the schema doesn't just ask for a summary of the case. It's demanding the extraction of the legal engine of that case.
Precisely. And that means a legal research platform can now index and query its database specifically for the underlying principles guiding the law, rather than just relying on, keyword searches within a massive unstructured document.
Which is a huge leap forward.
It makes legal research exponentially faster, but more importantly, it ensures conceptual accuracy. If the AI fails to isolate that binding principle, the structured output validation fails, and the user knows immediately that the agent missed its mark.
And linking that to the final order is key for compliance and actionability, right?
Yeah.
I mean, knowing the principle is academic, knowing exactly what was ordered, who pays what, who goes where, that's the operational reality.
It connects legal theory to practical execution. And to take this a step further, let's look at the case comparison schema, S1.2. It's not just summarizing two cases side by side.
Right. It forces the AI to structure the relationship between them.
Yes. The schema demands separate, bulleted lists for similarities and differences, which then leads to a structured conclusion. You're basically forcing comparative legal analysis, which is the cornerstone of developing any kind of legal strategy.
That's really powerful. You're forcing the AI to adopt a lawyer's mindset, not just absorbing information, but critically assessing its applicability across different scenarios.
And then let's move to a situation where the input data itself is messy, like during the litigation prep phase. I'm fascinated by the evidence chart schema, S1.4. This looks like a highly specialized operational tool.
It is a phenomenal example of AI moving from being a summarizer to a genuine analyst. The structure dictates a list of evidence items, and for each item, it requires fields like item number, type like documentary or testimonial description, source, and relevance.
But the real aha moment here has to be that explicit mandatory contradictions field.
Exactly. When an AI agent ingests a huge file of evidence, witness transcripts, emails, documents, the schema is telling it, for this specific piece of evidence, you must look across the entire corpus of evidence and identify any internal inconsistencies or conflicts.
So the AI is explicitly told, perform internal integrity checks. This is high-level analytical automation. It's crucial for litigation prep, identifying where the opposing side's argument or even your own internal documents might conflict.
It is, but this is also a great point to bring in the technical reality. What happens when the underlying data is low quality? Say, a poorly scanned document where the opto character recognition, the OCR, is flawed. Does the schema help with that?
That's a great question. The schema itself doesn't fix the underlying data quality, but it does enforce integrity checks downstream.
How so?
Well, if the AI is trying to populate the source field for an evidence item and the source name is illegible because of bad OCR, the LLM might hallucinate. However, because we're using tools like Pydantic or the response format parameter in modern APIs, the schema validation step will either force the AI to try again or the output will just fail outright.
So the rigidity serves as a fail-safe. It prevents bad data from getting into the database unnoticed.
The schema becomes the gatekeeper for data quality. If the AI knows it must populate the relevance field with a certain degree of confidence, it's much less likely to synthesize information based on faulty input. It enforces caution.
And we see that same principle applied to proactive legal creation too. Looking at the contract draft schema, this is a complex, nested structure. You've got definitions, parties, terms, obligations, termination, governing law.
This is the compliance checklist function in its purest form. A contract isn't just a document. It's a meticulously crafted machine where every section serves a distinct purpose. By forcing that nested structure, the AI can't accidentally omit critical elements.
For instance, the obligation section itself might be an array, forcing the AI to list out every single specific duty for Party A and Party B.
Or think about the termination object. It could mandate that there must be a notice period field and an indemnification clause field. If an AI is generating a contract for, say, software licensing, and it forgets to include an essential intellectual property assignment clause, the schema will flag that absence immediately.
It ensures that the generated document, even if it's just a draft, is structurally sound and compliant with common legal requirements from the get-go.
Exactly. It moves the human lawyer's role away from meticulous structural review like, did they remember the jurisdiction clause? And towards high-level conceptual review, is this the right jurisdiction? The structure guarantees completeness. The lawyer provides the wisdom.
And we see other schemas for enforcement and analysis, like the legal notice schema, S1.5, which enforces fields like recipient, violation, demands, and a deadline. This ensures the communication is legally sound and actionable.
and the oral submission schema S1.9, which demands the AI break down courtroom arguments into structured sections, opening statement, detailed legal arguments, and specific case law citations. When a junior lawyer needs to quickly review a senior counsel's argument, they don't need the flowery language. They need the structured breakdown of the core legal spine, and this schema provides exactly that. The entire legal section really demonstrates how structure professionalizes AI output.
Okay, let's move from the absolute precision of the legal world to the demanding complexity of personalized learning. This next section covers 10 schemas that are critical for education and, of course, the focus of the Digital Future AI School. How can structured data revolutionize learning and assessment?
Well, the promise of AI in education personalization at scale, instant feedback, it's entirely dependent on structure. If a lesson or an assessment or a progress report is just unstructured text, the AI can't efficiently track, compare, or adapt.
It's just more words.
It is. These schemas automate pedagogical workflows by turning curriculum data into structured, actionable educational material that integrates seamlessly with, say, a learning management system, an LMS.
So the foundation of any curriculum is the lesson plan. Let's look at the lesson plan schema, S2.1. It mandates a really comprehensive structure. Grades, subject, topics, specific, measurable objectives, materials, steps, activities, and assessment.
The crucial element there is the inclusion of measurable objectives. In free-form text, an AI might just wax poetic about a topic, but a rigid schema forces it to define the required learning outcomes. This ensures the plan isn't just creative, but it's pedagogically sound. It can adhere to regulatory or institutional requirements.
And that structural requirement also ensures consistency across multiple plans, which has to be vital for a large institution or a digital school that's using many AI agents.
Absolutely. Imagine asking the AI to adapt a ninth grade history lesson plan for a fifth grade audience. By knowing the exact objective structure, the AI can efficiently recalibrate the complexity of the materials and the assessment components without having to rewrite the entire narrative from scratch.
That structure is what allows for scalable modification, and it flows directly into assessment. The MCQ generator schema, S2.2 for instance, it requires a list of questions, each with a question, specific options, and the correct answer.
That's simple enough for generating a quiz, sure. But the key element that transforms this from just a testing tool into a real learning tool is the mandatory explanation field.
So the AI is forced to generate the reasoning at the same time it's creating the question and the answer. This is the structural leap from mere assessment to active learning.
Exactly. When the student gets the answer wrong, the system delivers immediate, context-aware feedback that's derived directly from the AI's own internal reasoning for creating that question in the first place.
That dramatically shortens the feedback loop, doesn't it?
Massively. Instead of the student having to wait for a teacher to grade and provide personalized comments, the AI provides an on-the-spot explanation, reinforcing the correct concept immediately. And all the research shows this immediate structured feedback significantly improves learning retention compared to delayed feedback.
It also ensures that the explanation is always there. In unstructured output, an AI might just skip the explanation if it thinks the answer is obvious, but the schema forces its inclusion, guaranteeing a comprehensive learning experience every single time.
And this structural rigor moves into administration, which is, often the most time-consuming part of a teacher's job. The Student Progress Report schema, S2.3, standardizes communication with parents and administrators.
That's vital for consistency and accountability. What specific fields in there make this report machine-readable and therefore so much more useful?
It includes the student's identity name, grade, and then a nested array for performance per subject, which includes the subject, a quantitative performance score, and qualitative comments. But it also has specific, standardized fields for attendance and overall recommendations.
Because the data is structured, the AI can track a student's performance over time. You could compare Q1 performance in math to Q3 performance in science and generate trend data without a teacher having to manually sift through pages of narrative reports.
Exactly. This creates standardized, comparable metrics that administrators can use to evaluate teaching methodologies or resource allocation across different classes or even different campuses. It moves educational reporting from subjective descriptions to objective, trackable data.
And for the student themselves, the exam preparation schema, S2.4, seems to take organization to the extreme. It moves beyond a simple checklist by using nested arrays to structure the study routine by day and by task.
It structures the student's entire routine into an actionable schedule. The main object contains a list of days, and then within each day, you have specific topics to cover and detailed practice tasks to complete.
I can see the immediate application here. A student prompts the AI for a study schedule for their biology final, and the output isn't just a long bulleted list in a text file. It's a perfectly structured JSON object ready to be fed directly into their Google Calendar or some dedicated study management app.
That is the definition of an AI agent acting as an automation engine. It's handling complex organization and integration automatically.
And we also see schemas dedicated to fine-grained feedback, like the teacher feedback schema, S2.7. Instead of just vague encouragement, the AI is forced to categorize its critique into structured lists of specific strengths and weaknesses, followed by actionable recommendations.
The structure minimizes ambiguity and focuses the feedback squarely on improvement. And the course outline schema, S2.8, structures entire courses by duration and nested modules and lessons. This ensures that any course generated by the AI adheres to a specific timeline and an internal logical flow. If the schema says there must be 12 modules, the AI delivers 12 structurally defined modules, period.
So the entire education section shows how rigid structure isn't restrictive, but it's actually enabling.
It is. It enables personalized feedback, standardized reporting, and compliant curriculum design, fundamentally improving both the learner experience and administrative efficiency.
Here's where it gets really interesting for a lot of our listeners. We're moving into the high-stakes, fast-paced world of startups and business. We have 10 schemas focused purely on execution and efficiency. If time is money, these schemas promise to cut the time needed to go from a nascent idea to an investor-ready document.
Business execution requires absolute clarity. Clarity on metrics, on the market, and on repeatable processes, your standard operating procedures. When entrepreneurs ask an AI to write a business plan without a schema, they often get a kind of motivational narrative. It's nice, but it's not useful.
Right, it's not actionable.
Exactly. Structured output ensures the AI instantly delivers investment-ready documents and operational procedures that adhere to the expected industry formats.
So let's start with that foundational check. The business plan schema, S.3.1. It mandates the core narrative components: problem, solution, market, competition, business model, marketing strategy. This ensures the idea is coherent.
It does, but the structural element that forces a genuine viability check is the financials object.
Absolutely critical. And inside that financials object, it specifically demands quantifiable fields. Startup costs broken down into categories like R&D and marketing, and a monthly revenue projection for the first 12 months.
This is that analytical leap we've been talking about. By forcing the AI to output these specific, quantifiable financial parameters, the schema guarantees that the core viability questions of a startup are addressed up front. It forces the human user to stop wasting time on a vague, purely theoretical idea and confront the necessary capital and operational requirements.
It forces rigor.
It saves founders months of time. If the AI, after analyzing market comps and typical operating costs, can't confidently populate those fields with realistic numbers, or if the numbers are wildly contradictory, the output is essentially an early warning system. It guarantees rigor and prevents the idea from stalling due to undefined financial planning.
So once the plan is structurally sound, you have to sell it. The pitch deck schema, S3.2, is basically the mandatory table of contents for an investor presentation.
It capitalizes on investor psychology. Investors review hundreds of decks, and they expect a standardized narrative structure. The slides array sequentially lists the expected flow: title, problem, solution, market size, business model, traction, team, financials, and the ask.
And if the AI were to generate content and put the team slide before the problem slide, an investor might just lose interest immediately because the narrative flow is broken. The schema minimizes that structural error.
It ensures compliance with the unspoken rules of Silicon Valley. Now, let's look at two critical operational schemas that drive efficiency, not just fundraising: the SOP schema, S3.6, and the KPI tracker schema, S3.9.
The SOP, the standard operating procedure, is all about defining repeatable action.
Correct. The SOP schema structures the procedure by standardizing the process name, the sequential steps required to execute it, the tools required, and crucially, the responsible person or role. This turns a complex, potentially tribal process into a repeatable, auditable series of steps.
And that responsible person field embeds accountability right into the procedure definition, making it enforceable.
It does, and the KPI tracker is the counterpoint. It's the structured system for measurement and performance tracking. It's the rigid framework for business intelligence.
So what does that look like?
The metrics array requires a metric name, a target value, the actual value, and a time period. This turns what could be a qualitative performance assessment into plug-and-play quantitative data. If an AI agent is tracking, say, monthly production throughput or lead conversion rates, this schema guarantees the output is instantly readable by a dashboard, a database, or even another AI running variance analysis.
This is the real shift. We're going from narrative business status updates to a defined data payload that's ready for API ingestion. It's how AI output integrates into traditional BI systems.
And we can't overlook the schemas that structure market understanding. Look at the market research schema, S.3.3. It forces the AI to break down its research into specific quantifiable segments: market size in dollars, growth rate as a percentage, and detailed customer segments.
So the AI can't deliver vague market chatter. It has to give you concrete decision-driving numbers.
And you link that to the customer persona schema, S3.7, which formalizes ideal client profiles. It forces the AI to categorize goals, pain points, demographics, and specific buying behavior. By enforcing this structure, you ensure that every persona the AI outputs is complete and comparable.
A marketing team can easily compare the pain points of persona A versus the buying behavior of persona B because those fields are guaranteed to exist rather than being scattered across some descriptive text.
It's all about consistency. The entire business section is geared toward leveraging structure to minimize cognitive overhead and maximize automated integration, making AI a true engine for efficiency.
Okay, we are now combining the final two major categories, health and multimodal workflows, because they both demand the most challenging aspects of data interpretation: synthesis, complexity, and critically, safety. Let's start with health, S4, which has 5 schemas.
AI in the health domain operates under maximum scrutiny. The output has to be cautious, accurate, and most importantly, helpful without overstepping professional boundaries. The schemas themselves reflect this caution. Notice that S4.5 is explicitly named the symptom interpreter schema, non-diagnostic.
That non-diagnostic caveat is an absolute structural necessity for safety and for liability management. But within those limits, how does structured output help translate complex, jargon-heavy medical data for the layperson?
The medical report summary schema, S4.1, is designed precisely for that, to bridge the communication gap between the doctor and the patient. It requires clinical fields like findings and impressions, which summarizes the medical view.
But the functional fields for the patient are the mandatory exclamation symbol and questions for doctor.
And that structural requirement is profoundly powerful. The AI is tasked with 2 critical functions. First, translating dense medical jargon into easily understandable language, and second, proactively identifying necessary follow-up questions the patient should discuss with their physician.
So it shifts the AI's role from just information processing to genuine patient cognitive support. It minimizes anxiety and improves the quality of the consultation because the patient comes in prepared with structured, intelligent questions.
We also see schemas dedicated to structured action, like the physio plan schema, S4.2. When it generates a rehabilitation routine, it structures the output into warm-up, specific exercises with sets and reps, and crucially, a mandatory precautions section. This ensures safety and consistency in unsupervised home treatment plans.
So if the AI generates a set of exercises but forgets the precautions for, say, a knee injury like avoid bearing weight, the schema forces that safety check. The structure itself is a safety mechanism.
Exactly, and that symptom interpreter schema, S2.15, reinforces that cautious approach. It forces the output to categorize information into possible causes general and a specific list of urgent red flags with contact instructions. It provides immediate, structured risk assessment without ever offering a definitive and potentially dangerous diagnosis.
That's truly a model for responsible AI development, isn't it? Structuring the output to serve a utility function while mitigating the primary risk.
It is. Now, let's pivot to the final and most technically advanced section: multimodal OCR audio-video schemas, S5. There are 10 schemas here, reflecting the reality that modern AI agents have to handle images, spoken word, video, and complex data retrieval, often all at the same time.
This sounds like the engine room of enterprise AI automation. Why is structure so essential when you're dealing with such diverse, messy data types?
Because when you process non-text data transcribing audio, extracting text from an image, there's a high risk of losing context or data integrity during the translation. You need a structured pipeline to guarantee that data flows correctly and reliably from the initial processing stage to the final actionable output.
And the ultimate example of this seems to be the image OCR RAG schema, S5.6.
Yeah.
This one schema structures an entire multi-stage workflow.
It does. RAG, or Retrieval Augmented Generation, is how an AI grounds its answer in specific verifiable external documents.
Can you give a quick, simple explanation of RAG for anyone who's just stepping into this technical side?
Sure. Think of RAG as giving the AI open book access to a library of trusted documents before it answers a question. Instead of relying solely on its general training knowledge, which could be old or inaccurate, it quickly pulls relevant passages from your specific verified corporate knowledge base or database. It prevents the AI from making things up.
Got it. So this schema forces the AI to structure that entire open book process, guaranteeing auditability.
Precisely. The schema breaks down the pipeline step by step from image text, which is the initial OCR output, to clean text, where errors are corrected, into searchable chunks, then to the specific retrieved passages from the knowledge base, and finally, the final answer.
What's fascinating here is that the schema itself maps the internal logic of a sophisticated AI system. It forces the AI to show its work. The input, the processing steps, the exact knowledge retrieved, and the final validated answer.
This is enterprise-level synthesis and auditability. If the final answer is questioned, an auditor can look at the JSON and trace every single step back to the source document, including the quality of the initial OCR. And this structure helps mitigate failure. If the clean text field is empty because the OCR failed, the RAG steps are skipped, preventing a speculative final answer.
And developers using modern LLM APIs, they would pass this exact JSON structure as the response format parameter, basically telling the model, your output is only valid if it adheres perfectly to this complex workflow.
That's right. Now consider how this synthesis converts passive media into active, actionable data. The audio transcript schema, S5.3, is far more than just transcription. It mandates fields for the raw transcript, a high-level summary, prioritize key points, and critically, action items.
So the moment a conversation or audio file is processed, the AI is immediately structuring the actionable tasks from that discussion, ready for export.
Yes. And similarly, the video summary schema, S5.4, ensures that analysis includes which frames extracted were important, the high-level topics, and specific time codes for reference. These formats standardize the analysis of media, making video and audio content instantly searchable, referenceable, and ready to feed into other automation tools.
And the culmination of these media synthesis tools often leads to the meeting minute schema, S5.0, which is arguably one of the highest value outputs for corporate productivity.
This is where discussion is turned into management. The schema requires fields for participants, the agenda, a discussion summary, and critical decisions made. But the structure's greatest contribution is the mandatory list of action items.
And each action item is structured with 3 vital pieces of information: the task description, the person it's assigned to show, and a definitive deadline.
That is instant, seamless task management. The passive discussion is immediately translated into structured, assignable, and trackable tasks. It eliminates the need for a human assistant to sift through notes, decipher intent, and manually enter tasks into project management systems. The AI agent, strictly guided by this schema, does that complex organizational job automatically.
This entire section absolutely underscores the transition we've been talking about. AI is no longer a tool for just generating text. It's a tool for generating perfectly structured, validated data payloads that plug directly into every enterprise system. Structure guarantees function.
So to summarize this extensive journey through these 50 schemas, we've really covered 5 major categories: the rigidity required for legal documentation, the pedagogical framework for scalable education, the efficiency and rigor needed for business, the caution and clarity required in health, and the complex data routing and multimodal synthesis.
Each one builds on the last, in a way.
They do. And these templates are not just helpful guides, they are industry-grade tools. They form the core logic for enterprise automation: custom ChatGPT agents, no-code apps, API workflows, you name it. They eliminate the messiness and the unreliability of raw large language model text, ensuring every delivery is a valid data payload.
And if we connect this to the bigger picture, the transition from AI generating free-form essays to AI generating these complex nested data structures like the ones we've seen in JSON, it really marks the genuine maturation of the entire AI agent ecosystem.
This is the moment AI becomes a functional tool for systems that demand precision above all else, and it shows that the human definition of structure remains paramount. The AI's genius is in its ability to perfectly fit its sophisticated output into the precise human-defined container we give it. We define the rules of the game, the AI executes the play perfectly.
These 50 templates, therefore, offer a profound shortcut to being well-informed. Not just about the theoretical potential of AI, but about how to build sophisticated AI tools that interact reliably with real-world, high-stakes systems. So what does this all mean for you, the learner or the builder? We've seen AI agents capable of structuring a binding court decision, a detailed physiotherapy plan, an entrepreneur's entire financial viability check, and board meetings action items. These are all structures that, until very recently, required highly paid human expertise to define and enforce. And now they can be automated. Exactly. So the ultimate provocative question for innovators right now is this: what currently human-defined structure, a detailed scientific grant proposal, a highly complex government regulatory compliance form, a massive engineering bill of materials, or even a specialized academic syllabus? What will be the next essential structure an AI agent needs to master?
Because the minute that structure is codified in a robust schema,
It ceases to be a manual bottleneck and becomes the next critical, non-negotiable step in an automated professional workflow. That is where the money and the leverage are right now.